Hi, welcome to Coadep Econs Academy. This is your place to sharpen your skills for critical question solving and for practical life experience. Today we're going to look at 5 ways of calculating elasticity. And we're going to do this at the general level. That means the kind of knowledge we're going to acquire here can be applied to elasticities of demand, supply, and so on and so forth. Before that, let's try to understand elasticity. When we talk about elasticity, we're talking about the responsiveness of a variable to a given change in its determinant. So when we have variable y and its determinant is variable x, and then there's a given change in x, by how much would y change? That degree of responsiveness is what we term as elasticity. This can be put mathematically in the expression E, where E stands for elasticity. So elasticity is equal to percentage change in y divided by percentage change in x. So in mathematical terms, when we talk about elasticity, then we want to measure the ratio of the percentage change in y to the percentage change in x. This expression here gives us the first method to work elasticities. So there are specific instances that you have to work elasticities using this expression. Let's take an example. The price of cell phone was increased by 0.5%, and this resulted in a 1.2% increase in the quantity of cell phones supplied. Let's calculate the elasticity of supply in this case. So both quantities are positive because they represent increase. We do the substitution. So this is the percentage increase in quantity supplied, and this is the percentage increase in price. When you simplify, you get 2.4. So elasticity here is 2.4. Now, apart from the first way of calculating elasticity using the expression up here, there are other things we can do. Let's try to expand this expression to get some formula. Percentage change in y is equal to new value of y minus old value of y divided by old value of y times 100. Let's put this up here. When we do that, this is what we get. Let's go on to find the formula for the percentage change in x. That is also given by new value of x minus old value of x divided by old value of x times 100. Let's pick this and also substitute at this point. When we do that, this is what we have. Observe that in the numerator we have times 100. In the denominator we also have times 100. They will cancel out. We're going to be left with this. Let's move on to remove this fraction and bring a division sign. And this is what we have. Finally, let's remove this division and turn it to multiplication. The moment we do that, we have to reciprocate the fraction at the right side. So we do the reciprocation and this is what we have. Remember that multiplication is commutative. So in the denominator, I can bring this term to the left side and pick this to the right side. When I do that, I have this. So we arrive at a formula for finding elasticity. All that the formula is saying is that find the change in the variable divided by the change in its determinant and multiply by the old value of the determinant divided by the old value of the variable. Let's take an example. So we have old price, old quantity demanded, new price, new quantity demanded. So from the formula, what we are supposed to do is that we will pick this new quantity and subtract the old quantity from it and put it up here. We will pick this new price and subtract the old price from it and put it at the denominator. Then when we come here, we will put here the old price, and down here we put the old quantity demanded. And as we do that, this is what we have. When we simplify, we have elasticity to be negative 10. So this is the second way we may be asked to find elasticity. Now let's move on. This way of finding elasticity is called the point elasticity formula. So we usually use this formula when the change in the determinant is minute, is small, is infinitesimal. So what we are saying is that when the change is small, so how small? So by rule of thumb, when the change is less than 1%, then we can use this formula. But if the change is more than 1%, then we have to move on to use another formula called the arc elasticity. The issue is this. When we are using the point elasticity formula, we are expressing the percentage change in the variable in relation to the old value and the percentage change in the determinant in relation to its old value. But if the change is so big, then it is rational that we express the change in the variable to the midpoint of the change, and also the change in the determinant to its midpoint. So that is the essence of the arc elasticity. It is acknowledging that the change is so big. So for us to get something that will not distort the fact, we need to use the midpoint. So as I said, when the change in the determinant is less than or equal to 1%, then we use the point elasticity formula. If it is more than 1%, then we have to resort to the arc elasticity. So the arc elasticity, as I said, we express the percentage change in terms of the midpoint. So the midpoint is to add the old and new value and divide by 2. Here also we add the old and new value and we divide by 2. Clearly you see that divided by 2 will cancel out and we'll be left with this. Now addition is commutative, so I can interchange the positions. And when I do that, I'm going to get the formula or the expression up here. So this is what we are supposed to use whenever we are using the arc elasticity. We find the change in the variable, we divide by the change in its determinant, then we add the new and old value of the determinant, and we divide by the sum of the new and old value of the variable. So in this case, when we come here, it is going to be 12 minus 10 up here. And down here is going to be 49 minus 50. Here we add 49 and 50. And here we add 12 and 10. Now, understand that when you look at the determinant, the old price was 50 and the new price was what? 49. This change, when you calculate, is more than 1%. So if you are not restricted in exams, then you should use the arc elasticity formula. Let's work it and see how things will be. We do the substitution, we calculate, and now how do we get? Elasticity is -9 instead of -10 when we use the point elasticity formula. So that tells us that when we use the point elasticity formula, the figure was overestimated in absolute terms. Alright, so we have seen 3 ways of calculating elasticity. Let's move on to the 4th method. We will start with the point elasticity formula. Now, when we observe this side, if we are to have a graph between y on the vertical axis, x on the horizontal axis, and that graph is a straight graph, then what it will mean is that the expression at the left side here is the slope of that graph. So the point elasticity formula is telling us that we take the slope of the function and we multiply by the ratio of the determinant and the variable, their old values. But it is not always that we are going to get a straight graph or a function that is linear. So in that case, what do? We need to resort to calculus. So in calculus, this slope will tend to dy dx. And in that case, x and y will just be any point. So when we use calculus, we can calculate for the elasticity at any point on the function. So instead of xo, yo, it will be just x and y. So this is another method for elasticity. dy dx times x over y. We use this especially when we are working with functions. The first 3 methods we looked at are mostly used when we are dealing with schedules, when we are dealing with graphs. But when it comes to functions, then we are good to go with the calculus. Let's take an example. We have this function, Q equals 100 minus 2.5p. At the point where p is 3, we are supposed to find the elasticity. Let's understand that because of this negative, we can assume this is a demand function. What do? We need to take the derivative of the variable with respect to its determinant. So we're going to take the derivative of Q with respect to p. When we do that, so derivative of Q with respect to p is -2.5. Now we need p and we need q. P has been given, so our duty is to find q. We move on, we use this function, we put in the value 3 and we work on to get the value of q, which is 92.5. So what we are having is that p is 3, at the same point q will be 92.5. Now, the slope dq, dp, is -2.5. So, our elasticity is the slope times p over q. And when we do that, we have -0.08. So, this is the 4th method. In the 4th method, we find the slope using calculus, then we find the point, and then we work for the elasticity. We are going to look at the last way in which we may be asked to find elasticity. Now, this formula with calculus, let's try to do something. what I've done is that I've interchanged the denominator. Let me go on to reciprocate the right side of the expression, this side. Let me reciprocate it. And I can only do that by changing the multiplication to division and reciprocate it. So what I see is that I have this fraction divided by this fraction. And I can put it in this form. This fraction over the second fraction. Now, in calculus, when I have the differential of ln y, it is equal to dy over y. Let's put that in mind. So dy over y is the same as the differential of ln y. In the same way, the differential of ln x is the same as dx over x. So this dx over x is the same as the differential of ln x. So let me do substitution. I pick this, put it here. I pick this, put it there. And I'll arrive at this. So this is also another formula for finding elasticity. It is quite useful when we are doing the practical work in economics and econometrics. Mostly when we run our regressions and others. This is what we usually resort to. And it is good for policy decision making. When we use this type of elasticity, all that we are trying to ask ourselves is that when there is a 1% change in X, by how much percentage change will Y experience? So when there's a 1% change in X, by how much percentage change will Y go through? Now let's take an example. We have this function, K equals P to the power 0.75 times C to the power negative 0.2. Now let's try to linearize this expression or function by taking the logarithm of both sides. When we do that, we are going to get ln K is equal to 0.75 ln P minus 0.2 ln C. Now let's try to find the elasticity with respect to P using the formula up here. So we have this expression. The elasticity is the derivative of ln K with respect to ln P. And that is simply 0.75. So the elasticity here is 0.75. What this is telling us is that whenever there's a 1% increase in price, quantity will also increase by 0.75% and vice versa. So that is the fifth way, and this will bring us to the end of our lesson. I urge you to subscribe, like, and share to promote my channel. Thank you for watching.